Biology is the study of life, whether it's tiny, simple organisms like this one, or giant organisms like this right whale.
But what defines life? Thinking about life on other planets, other solar systems, even other galaxies is what astrobiologists do every day. What will it look like?
Astrobiology is the study of the origin, evolution, distribution, and future of life in the universe, extraterrestrial life, and life on Earth.
Let's think about what organisms will look like on other planets and how far we are from our neighbors.
We're here on the Harvard-MIT bridge to show you how far apart the planets would be in the solar system measured in meters and smoots. I'm Mercury. On Mercury, there's no weather, so there are no storms. During the day, it can reach up to 801 degrees Fahrenheit because of its proximity to the sun, and during the night, it can reach negative 279 degrees Fahrenheit because there's no atmosphere to trap the daytime heat.
The force of gravity on Venus is only 12% less than we have on Earth, but the extreme weight of the atmospheric pressure would crush a human. Apart from the moon, Venus is the brightest thing in the night sky.
Earth's surface is made up of both land and water. The atmosphere of Earth is made up of nitrogen, oxygen, and carbon dioxide. That's the stuff we breathe. The Roman god of war. It has a really thin atmosphere, which is really, really cold. And the gravity is 62% lower, so you're not being pushed down as much.
In the asteroid belt, 50% of the asteroid belt's mass is from 4 different asteroids. The average distance between asteroids is around 600,000 miles.
Jupiter is a gas giant. That means its entire surface is made up of a large ocean. And covering its surface are a bunch of giant storms. Jupiter's famous red spot is a huge super hurricane.
Saturn is a gas giant known for its rings and moons, but Saturn also has winds up to 1,800 kilometers per hour and storms that are bigger than the Earth itself.
Uranus can be pronounced 2 ways, Uranus or Uranus.
Wait, that's Neptune.
I'm Uranus. Uranus can be pronounced 2 ways, Uranus or Uranus.
Oh! Neptune! No!
Let's put it on our head.
Oh no!
Is there water in Neptune though?
No! It's a gas giant. I don't know, just...
What kind of joke we make about the gas turning into a liquid?
You wanna just hold it?
Well, Neptune's the god of the sea, so... This is Neptune, named after the Roman god of the sea. It has a very active climate with an average temperature of negative 214 degrees Celsius. And this is Pluto. Scientists believe that it's 50 to 70% rock and 30 to 50% ice mass, and it only has an atmosphere sometimes.
Did you know that because of the shift in gravity, the fluids in the body redistribute so that astronauts get puffy faces and skinny legs? Now you know.
Now you know! Consider the following.
According to NASA, in space, the lack of gravity causes blood, which normally pools in the legs, to collect in the upper body instead. This means astronauts' faces get puffy and they get chicken legs. On Earth, gravity pulls everything down, including our fluids. The lack of gravity in space causes these fluids to come back up, making you bigger on top. Sometimes, during re-entry, astronauts will pass out because the reintroduction of gravity causes all of the blood that pooled in their upper body to rush back down to their legs.
Check this out!
Rocket Team is a challenge team from Science Club for Girls.
Divided by velocity, right?
Okay.
So now, this is delta t. We'll erase that. And what do you put in there?
Okay, so when you do legs divided by velocity?
Yes.
We meet every week on Tuesdays at Aurora Flight Sciences, where we generally build, design, and test our rockets for this competition called TARC. In the first half of the year, we design our rockets using a simulator called RockSim, and then we build it in the lab. In the second half of the year, in the cold, cold winter, we go outside and we launch them. As you can imagine, the snow kind of dampens the mood.
Are we gonna count down? Or are we just gonna...
5, 4, 3, 2, 1.
Blast off! Hillary Point!
4, 3, 2, 1, launch.
Whoa! Oh my gosh!
That's awesome!
Rocket Team is super fun.
Did you know?
Did you know that you're actually taller in space because gravity isn't pushing down on your spine? Now you know.
Now you know. Consider the following.
When astronauts spend a significant amount of time in space, they can become up to 3% taller. Because of the lack of gravity, vertebrae in the spine can expand and relax, and the discs in the spinal column also decompress, which causes the spine to lengthen overall. This phenomenon is comparable to how a spring works. When you push down on it, it stays coiled tightly, and when that force is released, it stretches back out. Luckily, astronauts' spines go back to normal after a few months of being home, as this force is returned due to gravity. Because astronauts wear custom-fitted pressurized suits for launching and landing, these suits need to be made large enough to compensate for this change in height. After living for nearly a year on the International Space Station, when he returned back to Earth, astronaut Scott Kelly had to be carried off the spaceship because his legs were so weak from the fluid shifts. He returned a whole 2 inches taller than his identical twin Mark, who was originally the taller twin.
So, we've been talking about astronauts so far, but how do they get up there? First of all, we'll talk about Newton's first law. Newton's first law states that an object stays at rest unless a force acts on it. And to demonstrate that, we can look at a combustion chamber. In this combustion chamber, there are air molecules. These air molecules are going into different directions, and as you can see, this air molecule going to that direction has an air molecule going to the opposite direction, and these air molecules force cancel out like that, and that, and that, and that. However, the gas chamber has an opening right here. And then the gas molecule going to this direction, the upward direction, doesn't get canceled out because the gas molecule that is going downward escapes the gas chamber. Therefore, the rocket moves upward. You can have your own combustion chamber, but without combustion. Whee!
so good.
Have you ever thought about making your own rockets? Well, we're going to show you how. What you will need are Scotch tape, water, a paper towel or tissue roll, a film canister, an Alka-Seltzer tablet, scissors, and a paper plate. So first, you're going to take your tissue roll and you're going to cut small slits at the bottom. The slits are going to be about 1 inch in length, and there's going to be about like 4 or 5. So after cutting the slits, you're going to bend them up like so. And taking your paper plate, you're going to tape the slits down with them folded up. So I can hold that. Next, you're going to take your film canister and you're going to fill it about 1/3 of the way with water. Next, you're going to take about 1/4 to 1/2 of your Alka-Seltzer tablet and you're going to put it into the film canister. And you're going to cover it, shake it a little, and then you're going to put it upside down into your tissue paper roll. And it will take about like a minute or so for the reaction to happen, and then the film canister will pop out.
Now let's try it!
I hope it doesn't hit you.
It
doesn't hit you.
There we go.
Did you know?
Did you know because of the lack of oxygen you can't freeze in space? Now you know!
Now you know. Consider the following.
So, what if you were to go out into space without your suit? First, you would pass out from lack of air after only 15 seconds. That is different from like here on Earth where you can hold your breath for several minutes. That is because in space there is a vacuum-like atmosphere which sucks the air out of your body so you can't breathe. So, would you freeze or would you burn? Well, in space, there's 2 varying degrees of temperature. It can go from being 260 degrees Celsius or 500 degrees Fahrenheit in constant sunlight, or negative 148 degrees Celsius to negative 234 degrees Fahrenheit in the shade. But would you freeze in these temperatures or would you burn? Well, like I said, there's a vacuum-like atmosphere. So this means that heat doesn't really leave your body that quickly. So you're not going to freeze. All that's going to happen is you're going to bruise. So you're not going to freeze. Next, are you going to burn? Not really. To burn, you need what is called a combustion equation, which means that you need to react carbon and hydrogen with oxygen to create CO2 and H2O. But in space, there's no oxygen, so you can't have this equation, and you can't have fire, or you can't burn up. So in space, you'll neither burn nor freeze. All that would happen is you would asphyxiate, which just means that you would not be able to breathe.
Hi, my name is Betül Kasar, and I'm an astrobiologist at Harvard University. I am not looking for little green men, although that would be fun. Instead, I am looking for microbes, the organisms that are really, really, really tiny, and trying to understand how they behave and what they do. As an astrobiologist, I am interested in understanding how life happened to be the way we see it today. And we have no way of traveling back in time. We don't have a time machine. But we can travel in time using math and using biology. And that is what I do. I guess the sequences, the DNA molecule of past, and then I bring these past DNA, as we refer to as ancient DNA, back to the present. So in some ways, I am traveling in time using biology and math. Astrobiology is a very interdisciplinary field. It hosts disciplines such as physics, chemistry, biology, astronomy, astrophysics. So any STEM field would really make you relevant to the field of astrobiology as long as you have an interest in the universe. And who doesn't?
Why did you decide to go into STEM?
It wasn't a decision like that. It kind of evolved to be that way. I just continued doing what I liked, and I liked to learn. And science was still is, a room into darkness that somehow provided light in my life. There was more to learn, and the more I learned, the more I realized there is more to learn. And I loved that. So that really drove me into STEM.
Can you describe your journey through STEM, like the different challenges you may have faced, or like the help that you could have gotten?
I think perhaps all right, let me think about this a little bit. I guess the lack of role models sometimes was challenging to me. That I had people around me, and none of them were scientists, but they all had qualities that inspired me. So really early on in my life, I learned how to stitch that together. Instead of looking or expecting one person or a group of people to give me everything I need, I learned to reach out and grab all the tools and skills that I need from whatever is available around me. So that was challenging. But I didn't realize that it was a challenge until later in my career. Looking back, I can see that it was hard. And also not fitting in any box was hard. Which also really made me realize that when you love something, you just have to go for it. And it is very powerful to be who you are. Just staying true to what you want, what your heart wants, and staying true to your own self can do wonders in life.
Can you describe how it was to be like a woman in your field? Like if it was like a problem or a challenge or anything like that?
I think being a woman is challenging regardless of which field you are in. Or if you're in business world, I think it's also difficult. And it's not that difficult for science either. We are still a minority group, and we face challenges that comes with that. being a woman is great, and being a woman in science is even better, because we do provide a very unique angle into scientific questions. Think about it, science is really old, and women have always been minority, and now we are here. So think about all the unique things we can bring into science. So that's cool.
So I know when you were describing your journey, you mentioned that there were different people who supported you. Can you kind of describe like who they were and like how they helped you?
My family members were immigrants themselves, and I learned early on that life is hard. Watching them adapt to a different culture, a different environment, was very eye-opening for me. It was very inspiring. I learned from my father that regardless of your situation, you should keep working. Just always stay focused to what you love and keep doing that, and nothing can go wrong. His work ethic, how he left home early on in the morning running for work, he loved what he did. He was not a scientist, he was not even an educated man, but that really motivated me, and I always told myself that's what I want to be. And also he never really talked to me in a way that maybe in a conservative country or a conservative culture, how a father would talk to a daughter. He did not raise me like a daughter. He did not raise me like a son. He raised me like a human being. I never associated myself with my gender. I always saw myself as a human being, almost genderless. And which is why it was surprising later on in my life when I realized that society sees me as from an angle of women. It was very surprising because I did not experience that from firsthand. This is a message for fathers. You know, they have a big role, I think, in raising their daughters and the future women. It's not always in the mother's shoulder.
That was some crazy UFO. Have you ever thought of making your own? Well, I'll show you how. Here's what you'll need. You'll need a PVC pipe, like the one shown here, some tinsel. You can use the one shown here, some scissors, and this is the tinsel here. Okay. So first, you're going to take 6 strands of the tinsel. So you'll lay out the tinsel. So what you're going to do is you're going to lay it out and tie the strands at one end. It's going to take forever. And then you're going to tie it about 6 inches or 15 centimeters at the other end.
Can you fast forward through this? And
Yeah. No.
So next, you're going to take your scissors and you're going to cut the excess strand after the knot. So this will be your finished orb. So now you're going to take the PVC pipe and you're going to charge it up. So that means you're just going to make it all saggy. Any way that you can do this is just by like rubbing it against your clothing, kind of like this, or like this. Okay. And now, the sides. And you're going to drop the orb down. Move it around it.
What is life? Is there life elsewhere in the universe other than the one we know here on Earth? Are we alone?
This is the number of possible civilizations in our galaxy that could communicate with us.
This is the rate of star formation per year in our galaxy.
This is a fraction of stars with planets.
This is the number of planets that could possibly support life.
This is the fraction of planets that can maintain life.
This is the fraction of planets that can support intelligent life.
This is the fraction of civilizations that could create and communicate with us and create a signal detectable from space.
And this is the length of time those detectable signals exist. And this is the Drake equation.